So today we are going to learn about this NodeJS internals, and before going forward, let's understand what happens internally. So what actually happens is whenever we write some code and try to execute it, suppose we have written node a.js, so it will try to execute the program, and when the program is going to be executed, what happens internally is it will first go to the where it will go? It will first go to the V8 engine, and the V8 engine have two things. The first one is the heap memory, and the second one is the call stack. Okay. After that, one more thing is that libuv. Whatever the async operation is there, the V8 engine will offload it to the libuv, and this is the libuv. JavaScript engine will offload the async operation to the libuv. And in the libuv, we have two things. The first one was the event loop, and the second one was the thread pool. So these are the threads. So I can say it as thread pool. So whenever any code comes or we try to execute it, it goes with this two-step cycle. Firstly, it will go in the V8 engine. The V8 engine will execute the codes, and if there is any async operation, the V8 engine offloads that operation to the libuv, where we have event loop and the thread pool. So this is what actually happens inside that. If I have to tell you, or if I have to explain you how the code will work, so suppose I have written here console.log a, then there is some function call, and it is function definition. Function a define that prints suppose b, then there is console.log c. So if I have to explain you how this code will execute or run in the memory, the entire workflow, so it will go like this. Firstly, this statement will be read by the main thread, and it will first go in the call stack, and then it says that it is a top level code, so it will execute it and print the a. Then it will go to the second statement. It will say that it is a function, so function will be there in the heap memory. So this function body along with all the content will be there in the heap memory. After that, it will go to the third statement, which is console.log c. So here it will say that okay, it is the printing statement, so it will print here. Now suppose there is another statement that is calling this function a. Now the function a will be there in the call stack, and it will see that there is a call stack, and then it will find that inside this memory, found it, and it says that you have to print b. So it will print b, and then it will vanish off from the call stack, and then when everything goes off, the garbage collector will arrive and see that okay, this function has no any reference and all, so it will just vanish out from the memory. This was the async task or the synchronous task which happens. Now if I have to add some asynchronous task inside that, suppose asynchronous task, what it is, suppose I have to read some files, so I will be using the fs modules read file, and something happens here, and there will be a callback. For the simplicity, I will say that this is a function. Okay. Now we have seen this statement. First, it will run this, and then and this. If there is callback, and then I am printing b. So what will happen is the main thread will start executing from here. First one, that thing happened. Then here, here. Then it will see that this is an async operation, and what it will do will come here, then see that okay, this is an async operation, so I will offload this to the libuv. So this function will go in the libuv, and it will perform its task independently. If that task is completed, what will happen? And then the main thread will go here, it will say it is printing d, it will go here in the call stack, it is d, then it will print the D, and it is removed from the call stack. Once the call stack is empty, now it will go to the libuv, and in the libuv there is this event loop. This event loop will start executing, and there are various phases in the event loop. I will be explaining it further. So let's first see what happens here. So once this task is completed, event loop cycle will then give this to the here. This function will come here again in the call stack, and then it will execute. Then whatever will be there, suppose it is printing F, so it will print F here, and then the program will stop. So this was the idea how this Node.js works from the upper level. I have to just double tap here in the Node.js to, not the Node.js, the event loop, to understand what happens internally in the libuv. So we will be doing that now. Let's go. So now let's start with this event loop. So event loop have various processes or phases, I can say, and whenever there is any async operation, it will go from these phases and then start executing the code. So let's see what are these phases first, and then we will try to understand what it is. So whenever there are so basically the first phase is the timer phase, where the timer operations are held there, or here the timer operations come. Those are basically set timeout and the set time interval. After that, the second operation is polling. Basically, if there is any input output, yeah, file read operation, or the heavy task, that will comes in this polling phase. Then the third phase is the intermediate phase, set immediate phase, and after that the close callback phase will be there, and now it will see that if there is any task completed, if every task is completed, this event loop will break down. If it is not, then it will again go to this timer phase. So this is kind of forming a loop. And one more thing, that it is a part of event loop, but there is a micro task queue which is basically not part of an event loop, but it is a part of Node.js, which is basically process.next, and the second one is promise. Second one is promise, and combinedly I can call it as event, not event, combinedly I can call it as the micro task queue. Now let's understand what are the phases, or how we can how the code executes inside this event loop. So whenever some async operations arrive, I will first check in this process.next. If there is nothing inside this process.next, I will go to the promise. If there is nothing inside this, then I will go with this timer. If there is any callback, suppose there are two callbacks. So what happens is, I come inside this timer and here is a callback. For the simplicity, I am telling it as function. So this function will start executing, and suppose this function start executing, and if let's say its execution is completed, so what will happen is, it will again, now this function execution is completed, now again it will check inside this process.next if there is present anything or not. Then it will go in the promise if there is present something or not. If there is nothing is present, then it will again go here and then start executing this function. Again the same process. It will complete this execution, then it will first check inside this process.next if there is something present inside this or not. If there is nothing present, it will go again in this promise. If there is nothing present, then again go back here. This is the function. It will start executing present. Now there is nothing inside my queue, then it will go inside this pooling phase. There is nothing present. Suppose there is nothing present here, so it will then go inside this phase. There is nothing present here, so it will go inside this phase. Again, there is nothing that is present inside here, so it will go back again to check here. But in our case, there is nothing in here, so it will check here. There is nothing present, so it will exit from this loop. So this is how a typical event loop functions. And this is it for this event loop concept. Okay, there is one more thing, this pooling thing. So what happens is, suppose there is the JavaScript works in the main thread. So this is a main thread. And if there is any CPU incentive task like reading the files from the computer or cryptography, or I can say password hashing, so these are all kind of CPU intensive tasks. So what happens is, it will go here and see that there is some CPU intensive task. So what it will do is, it will offload the task to the threads. I can say it as threads, which is also known as the workers. So if there is any CPU intensive task, it will offload it to the server threads, which is also known as the workers, and it will perform its task independently. And in the meantime, it will ask again and again to this thing that, okay, the task is completed or not. Now tell me the task is completed or not. Now tell me the task is completed or not. And the thing which I am just asking again and again, this concept is known as pooling. Asking a thing again and again to check if it is completed or not, which we call as polling. So these are the concepts that we have discussed here. So this is all about event loop. So this is it.